provider router and provider edge
Edge.
router, right? So here again in the service provider network, you are going to run any IGP protocol, and which IG protocol we are running, guys?
OSPF.
OSPF, right? And we are already done with OSPF, so just we need to enable the OSPF here. We have already covered all about OSPF. First we have covered the OSPF only, basic to advanced, then BGP. After that, MP BGP. After that, L3 VPN, right? Then L2 VPN. And now we are going to understand what MPLS forwarding. How routers in the service provider networks are going to forward the traffic without having route in the routing table. Like router 2 and router 3 will not have customer routes in their routing table, but these routers need to forward the traffic. Fast forwarding. Yes, na? That was the problem. Remember the L3 VPN. The ping was not working between the two sides of customer. Then what we did? We had enabled the MPLS, and after that ping has started working. Am I right? So what provider routers will do? Provider routers will forward the traffic based on label, not based on destination IP address. Can anyone tell me the default behavior, guys? Forget about the MPLS, label based forwarding, or even the SAF. Tell me the normal forwarding. We are already done with these all topics, and now MPLS, today topic.
Route forwarding.
Yes, forwarding with the help of RIB. Let's say here I have one router,
Routing
R1,
information base.
I2, and we have one server on router number 2 for an example. Here we have one
Sir,
server.
kindly make sure that we are recording, sir. Just to reach it.
Yeah, we are recording. See the red line here. This is the server. Server is having IP, let's say 20.1.1.1, R1 and R2. Between R1 and R2, the same subnet is running 12.1.1.0. So guys, here if I have one PC on router number 1 connected to router number 1, want to access the server. This PC is having IP, let's say 10.1.1.1, and want to access the server. Tell me the packet processing on router. How router is going to process the packet? First of all, definitely you have to inject the routes in the routing table of router. Am I right? Router 1 should have 20 routes in the routing table. By default, router 2 will only have 12 and 10 in the RIB table. Here IP is 12.1, here IP is 12.2. So by default, if I will talk about the routing table of router 1, guys, how many prefixes will be there in routing table of router 1 by default? After configuring the IP addresses,
1.
2 subnet will be there, no brother? Two networks are directly connected. 10 and 12. Yes, 10 and 12. But we need 20 subnet. If 20 subnet is not there in the routing table of router 1, then router 1 cannot forward the traffic for 20 subnet. So if you are going to ping, let's say 20.1 from PC, or you are going to send any traffic, let's say HTTP traffic, this is my web server. Web server. So if you are going to generate HTTP traffic from the PC, HTTP request message, source IP will be 10.1.1.1, destination IP will be what? 20.1.1.1. And PC is going to check destination IP belongs to same subnet or different subnet. So destination IP belongs to different subnet. Router will forward it to their gateway. Am I right? PC will forward the traffic to gateway. Gateway is router 1. Right? For an example, here IP address is 10.100. 10.100. So 100 is the gateway. Source MAC will be the MAC address of PC1, and destination MAC will be the MAC address of gateway. Maybe it will generate the ARP request message for gateway to resolve the MAC address. But the destination MAC in actual traffic is going to be gateway MAC address. And when router 1 will receive this request, what router 1 will do? it is going to compare destination IP with routing table, and route will be not there, so router 1 will discard it, correct? So what you will do for routing? For the routing, you are going to enable any routing protocol here. For an example, OSPF. In most of the cases, we are running OSPF. So here I am assuming IGP protocol is OSPF between router 1 and router 2. Now through OSPF, router 1 is learning 20 subnet and router 2 is learning 10 subnet. So now can anyone tell me the process on router? Like when this PC is generating the HTTP request message, how routers are going to process the traffic? Here I am assuming MAC address A. Here I am assuming MAC address of gateway is B. Here MAC address is C. Here MAC address is D. And here E and F. Who will explain the complete process, packet processing by router 1 and router 2 when client is generating HTTP request message for server, when 10.1 is generating HTTP request message for server?
Sir, first it will resolve the DNS, and then it will check the destination gateway MAC address. If gateway MAC address
See,
is
the
there, then it
DNS
will
resolution and those all things will happen on PC, right?
yes, sir.
Routers are not going to perform any DNS checks.
Yes. Oh, correct. So it will start looking for the routing table. First, it will check the routing table.
When
and
router will receive the
and,
traffic,
it
first
will
of all,
check
it is going to check layer 2 header.
Yes, exactly. Whether the traffic is for it's himself only or not, it will check that one
If
based upon the MAC
destination
address,
MAC address is the MAC address of router 1 receiving interface, then it will accept.
receiving interface.
Or it is broadcast,
Correct.
then also it will accept.
Accept.
After the accepting, router
sir.
will remove layer 2 header, correct?
Yes, sir. It will check the type field also, which
Correct. Very
which
good.
protocol, I mean, is upper layer protocol.
In the Ethernet
Then
header, it
based
will
upon
check
that,
type field
yes, sir.
to identify the network layer protocol. Okay, very good. Now,
Then it will check the destination IP address, and it will check in the routing table whether it is having the destination route for destination or not. If it
destination
has
IP
the
address.
destination, then it will check the MAC. Yes, then it will check the MAC table for destination MAC. Correct,
When
sir?
router 1 will receive the traffic, it will remove layer 2 header. After verifying the MAC address, it will check type field to identify upper layer protocol. At network layer, it is going to compare destination. It will look up for destination IP address. Destination IP address is 20.1.1.1. First of all, the destination IP address belongs to router 1 or not, guys? The destination IP address belongs to router 1? No.
No.
So router 1 will decrement in TTL by 1, and it is going to check exit interface for 20.1 for destination IP address. How? It will
Sir,
run command show IP route 20.1.1.1.
Yes, sir.
Router need
So,
two things: the
yes,
gateway
sir.
and exit interface. Gateway is 12.2 and exit interface is maybe F0/1.
Sir, when this TTL value will be decreased, when the packet is going forward, that time it will reduce the TTL value, no, sir?
Yes,
Or before, it will not reduce the TTL value before looking into the routing table, right, sir?
correct. Before identifying the destination IP address in the packet, if the destination IP address belongs to router, that means the traffic is for router only, right? Then router will check protocol field.
Yes.
Then router will check protocol field to identify upper layer protocol or upper information, higher level information. But the destination, if destination does not belongs to router, then router will compare destination with routing table, and it will add new layer 2 header, decrement in TTL by 1, and after that it will forward to router 2. So this process is, guys, removing L2 header, comparing destination IP address with routing table, and taking forwarding decision. So for an example, between PC and server, if 1000 devices are there, if 1000 number of routers are there, usually we are going to connect two sites through service provider, right? I am assuming this is customer side 1, this is customer side 2, and both sides of customer are connected through service provider. So service provider network is connecting 2 cities, maybe 2 country. So there will be so many routers, yes or no? And if all the routers are going to perform RIB based forwarding, RIB based forwarding means checking destination IP address in the routing table, like router is scanning the routing table to find the gateway and exit interface, then guys, there can be latency, delay, more delay, right? Because on every router we will have processing delay. Routers are performing encapsulation, decapsulation for layer 2 header. It is scanning the routing table every time, and if all 1000 routers are going to repeat the same checks, then there will be latency, right? Maybe you are not able to use the application smoothly. You will get slowness. If some videos are there on the server, right? Maybe it is buffering. If someone is talking on call, for an example, this is calling server, then again there will be issue, packet drop because of latency. So how service provider can improve the performance here, guys? If so many routers are there between source and destination, we need another types of forwarding method. You know, before RIB based forwarding, we were using packet switching. Packet switching is RIB actually, packet processing. Nowadays, to understand the routing protocol, you learned RIB based forwarding, like how routers are building the routing table and how routers are forwarding the traffic. And now you are learning how to improve the performance. So to improve the performance here between source and destination, first we come up with another types of forwarding, that is called FIB. This is RIB, routing information based forwarding. Then we come up with FIB, which is SAF, Cisco Express Forwarding. Cisco Express Forwarding. We come up with SAF. What is SAF, guys? What is FIB? Any idea?
FIB is forwarding information base, which will having all the routes, best route, I mean all valid routes, and RIB is the routing information base, which is having best routes.
No, in
Which is
RIB
routing
and FIB, in both the table we will have best path. We will only have best path in RIB as well as FIB. But guys, in RIB, see, there are so many information like network ID, yes na, subnet mask, AD value, metric, exit interface, next hop IP, right, etc. These are the part of routing table, RIB table, am I right? These are the information inside the RIB table of router. And even RIB is a part of, it is a part of control plane. Which plane? Control plane. And you know control plane is a part of CPU. Right? So whenever router is forwarding the traffic, it is using their CPU. And many things are there inside the RIB table. The detailed information of network. So if you will enable the SAF, what router will do? Router will make one duplicate copy of RIB. Make a duplicate copy of RIB. But it is not going to copy all the informations. First of all, SAF or FIB is a part of it is a part of data plane. Data plane. Can anyone tell me the difference between data plane and control plane?
So
Can anyone?
control plane is brain of the device, and it will take the decision where to forward the packet, and data plane is like it will forward the packets.
Control
Like
plane makes the routing decision
yes,
where the route the traffic, where to forward the packet, and the data plane actually use that routes to forward the traffic, right? Data plane
yes, sir.
uses that information to forward the traffic. That is the difference between control plane and data plane. Now SAF or FIB is a part of data plane. So what SAF will do or FIB will do, in the FIB guys, now we will make a duplicate copy of RIB, but here we are only going to copy a few things. See, to forward the traffic, router only need what? Exit interface and next hop IP address. That's it. This is also called adjacency table. So it will copy network ID and exit interface and exit interface. That's it, to forward the traffic, right? So see, for SAP based forwarding, like if you are going to enable the SAP, it doesn't mean router is not going to maintain RIB. RIB is still required because SAP is creating a FIB table on the basis of RIB only, right? How it is going to improve the performance? It is going to improve the performance while forwarding the user data, the actual packet. While forwarding the actual packet, it will not look up RIB table. Now RIB table is required to create a FIB table. That's it. Is it clear?
So in SAP, sir, network ID and exit interface.
Exit interface.
Okay.
Because these two informations are required to forward the traffic, right? But to maintain the guys best path table, a table to store best path, definitely you have to carry AD value. Then only you can compare best path metric. Right? So now if you are going to enable the SAF, then whenever router will receive the traffic on the interface, it will not compare the destination IP address with RIB. It will compare the destination IP address with FIB. With FIB. Here what we can do to understand it, and after the SAF is for enterprise network, not for service provider. When you have, let's say 10 routers between source and destination, you can use SAF there. Even SAF is not sufficient for service provider router, because in the service provider network, because in service provider network we will have lots of routers. So this was my first forwarding, RIB, that you need to learn. Then FIB, and after that the third forwarding is your MPLS. Third forwarding is your MPLS, right? So here if I will configure this lab guys, let me access routers, router 1 quickly. Let me show you. By default SAF is enable or disable?
It's enable.
On latest routers by default SAF is enabled guys. On some older routers it might be possible SAF is by default disabled. Then you have to enable the SAF.
So for enable the SAP, we have to use IP routing.
IP SAF command.
IP SAP command. Then when we use IP routing, sir, there is
IP
one
routing
command,
is
right?
used to enable RIB routing.
Okay, that
On
will be on
MLS.
L3. So
Yes.
okay.
No cert and IP address 12.1.1.1 255.255.255.0 and do so IP route. This is the command to check which table, RIB or FIB?
RIB, sir.
RIB.
RIB.
Right, and you can see in the routing table, in the RIB table, there are two networks. If I will open any networks in detail, like 10.1.1.0, you can see all the attributes. The metric, connected, interface, exit interface, right? Route metric is 0, traffic share count. Many more informations are there with your prefix, your subnet. And here, if I will try to disable RIB, no IP routing. See guys, the command is, sorry, no IP routing. See, no IP routing. Now I have disabled the routing, and let me show you the routing table. Do so IP route. What it's showing? Nothing, because we have disabled the RIB as well. We have disabled the routing on router. Now this router is acting as an end device. Now you can use this router as a server. Right? Let's say in the company I have one router with end of life. Right? Let's say support is not available for that router. Right? We are not able to update the iOS, the security patch file, those all things. So because of that, we are not able to use it in production. I can use that router as a DHCP server. I can use that router as a DNS server. I can use for other purpose by disabling the routing. But the main purpose of router is maintaining the routing table, RIB. RIB is the main function of your router. Right? So see, when I have disabled the RIB, now I am not able to see the routing table. And it's saying gateway is not set. Again I am saying IP routing. It will enable the routing table. Now you can see the RIB table. I am able to see the RIB table. Right? And no IP SAF. By default, IP SAF command is enabled. So I have disabled the SAF also. Right? And to enable the SAF, you will use this command. For the MPLS guys, SAF is mandatory. Because as I told you, for the SAF, RIB should be enabled. Because SAF is going to create adjacency table based on, or FIB table based on RIB table. Similarly, MPLS is going to create label table on the basis of SAF. If SAF is disabled, then MPLS will not work. For MPLS, you have to enable routing as well as SAF and then MPLS. Then only it will work. And now here, if I will show you the adjacency table, so IP SAF. So here you can see, so IP SAF. So here you can see the adjacency table, guys. This is my adjacency table. Ignore these multicasting and broadcasting like the other entry. Loop back. It is dropping the traffic, these traffics for now. Here we have the attached network 12.1.1.0/24 and 10.1.1.0/24. These two subnets are attached here on the this interface and this interface. If I will disable the SAF, no IP SAF, then you cannot check FIB table. So IP SAF, this is the command to check FIB. Now what it's saying, IPv4 SAF is not running. Clear? So SAF should be enabled. For now, just ignore the SAF. SAF is disabled. Let me enable the routing protocol OSPF router OSPF1, and here I am going to say router ID 1.1.1.1 and network 0.0.0.0, submit mask wildcard mask 255.255.255.255 and area 0. So IP OSPF interface brief. You can see OSPF is enabled on both interface. Let me take you to router 2 and let me configure it. Interface F0/0 no cert and IP address 12.1.1.1 sorry 255.255.255.0 and exit interface F1/0 no cert and IP address 23.1.1.2 255.255.255.0 exit router OSPF1 router ID 2.2.2.2 and then network 0.0.0.0 wildcard mask 255.255.255.255 and area 0. I am expecting OSPF neighborship here. Go to router number 3 and let me configure the IP interface F0/0 no cert and no cert and IP address 23.1.1.3 255.255.255.0 exit interface F1/0 no shutdown and IP address will be what 34.1.1.3 255.255.255.0 exit router OSPF1 and router ID 3.3.3.3 and network 0.0.0.0 wildcard mask 255.255.255.255 and area 0. Here also I am expecting OSPF neighborship and finally let me configure router 4 interface F0/0 no shutdown and IP address 34.1.1.4 255.255.255.0 and interface F0/0
Wrong interface F/0/0 is 20 network.
Here we need to replace the IP. Very good, thank you. 20.1.1.1 and interface F1/0 should have 34, right? No cert and IP address 34.1. Router OSPF 1 router ID 4.4.4.4 and network 0.0.0.0 wildcard mask 255.255.255.255 and area 0. Now guys, I am expecting reachability. Just wait for few minutes. Here you can see we have OSPF neighborship. Router 1 has one neighbor with 2.2.2. Very good. On router number 2, you can see two neighbors are there, 1.1.1 and 3.3.3. Very good. On router number 3 also you can see two neighbors are there, 2.2.2 and router 4. And on router number 4 we have one neighbor. And so IP route OSPF. So IP route OSPF you can see 10 subnet is there, 10.1.1.0. And on router number 1, so IP route OSPF 20.1.1.0/24. Now if I am going to ping these two LAN subnet 20.1.1.1 and source 10.1.1.1, then ping should work. You can see ping is working. And how much time it is taking, guys? How much time it is taking? The average time is 87 seconds. Maximum time millisecond, 87 millisecond. Maximum time is 112 millisecond. You know, 112 millisecond is the deadline for voice traffic. 150 millisecond is deadline. If the delay is more than 150 millisecond between source and destination, you will get drop. For the voice, voice is delay sensitive traffic. Voice is delay sensitive traffic. Delay should be minimum for voice traffic. So if I want to improve the performance here, I want to reduce the delay between 10.1 to 20.1. What I can do? I can enable SAF here. IP SAF and router number 2 also. But first of all, no IP SAF. Let me disable the SAF on all the router and let me check the delay. No IP SAF on router number 4 also. No IP SAF. And let me say here also no IP SAF and let me ping now. See the delay. When SAF is not enabled, repeat 100 packet. For the testing, you will always use ping with repeat command. This can be the output. This is the output. Minimum delay is 64 seconds. And after enabling SAF, I am expecting better performance. IP SAF. Here in the simulation, it might be possible it will show you same output, but guys, on the real devices in the production, there will be difference in the delay. Now let me ping 100 packet again. Here it's showing same, right? Average delay 86 seconds. In the simulation, it is showing same delay, but SAF is faster than RIB. SAF is faster than RIB. And now if I will enable the MPLS, again it can boost the performance. It can reduce the delay. Right? Now if you will check SAF here, let's say for 20 submits. If SAF is disabled, then router will forward traffic with the help of RIB. So IP route 20.1.1.20.1.1. Like this it will check routing table. If SAF is enabled, then router will not check RIB table to forward the traffic. It will check so IP SAF and 20.1.1.0. 20.1.1.0. And here you can see the output. This is the SAF output and this is your RIB output. SAF output and RIB output. Right? Both are similar, but MPLS is, guys, different. MPLS is new technology for you. Can I move to the MPLS forwarding now?
Yes, sir.
Is it clear to everyone?
This Cisco Express forwarding is only for Cisco device, is it?
Yes.
Okay. So what if we have other vendor like HP or
MPLS and RIB table?
only MPLS and RIB?
Yes.
Okay.
Any other
Sir,
question, guys?
sir, chef table, this also maintains the flows or not? Switching flows.
Switching. See, this is router. Router does not maintain the flow. That is a stateful inspection, a stateful behavior. Router does not support a stateful. That is firewall. That is the concept on firewall.
Okay.
1 minute, guys. Okay, this is stateless behavior. You know why Palo Alto firewall is popular in the market? Because Palo Alto comes with a stateful behavior for the first time. First time Palo Alto only comes with stateful. And don't worry about the stateful, stateless. That is not our concern. Let's understand the MPLS now. MPLS forwarding. Let me open the paint. So first type of forwarding is RIB, second type of forwarding is FIB, and third type of forwarding is MPLS. MPLS stands for what?
Multi-protocol level switching.
Multi-protocol label switching.
Protocol label switching.
Multi-protocol label switching. Means this is, guys, switching. Switching means what? Switching means forwarding only. Forwarding or switching packet from one interface to another interface. That is switching. So it is one kind of forwarding. It is one kind of forwarding. What is MPLS forwarding? MPLS, and we should say MPLS forwarding always. MPLS is a forwarding. Types of forwarding like your RIB and FIB. MPLS forwarding. What is MPLS forwarding? Anyone? Multi-protocol label for
Forwarding
switching.
based on the forwarding based on the label.
Yes, it uses labels labels instead of IP lookup. It uses labels instead of IP lookups to forward packet.
LIB and LFIB.
Yes,
FIB and LFIB.
very good. And this can speed up the forwarding, which provides more flexibility, right? This forwarding, label based forwarding, can speed up the forwarding process. Each router in the service provider network or in MPLS cloud, in MPLS network, forwards packet based on labels instead of IP routes. In the service provider network, routers will not check routing table. It will not perform IP lookup. But if MPLS is not enabled, then definitely router will look up routing table, IP routes. If MPLS is enabled, then it will perform label based forwarding. Now guys, here we have some concept. See, when router will receive the traffic, let's say R1 in my case, when the user is going to generate the traffic, user will generate normal traffic, right? User don't know about the service provider network, about the MPLS or any types of forwarding, like what forwarding method you are using on the routers. Users are not aware about that. User are going to generate normal traffic, source IP 10.1.1, destination IP 10.1.1.2. Yes, na? And it will forward to R1, router 1. How router 1 will perform label based forwarding, guys? If the exit interface is MPLS enabled interface, if MPLS is enabled on exit interface, then this router is going to push the label, is going to insert the label, is going to add the label with this packet. What will happen? If the MPLS is enabled on the exit interface, see, when router will receive the traffic, router 1 will definitely receive the traffic on LAN interface. On the LAN on this F0/0 where MPLS is not enabled. So router is receiving normal IP packet. This is not labeled packet. But exit interface is MPLS enabled interface. MPLS is enabled on exit interface. So R1 is going to add MPLS header here. What it will do? It will add the MPLS header. And in the MPLS header, there will be label information. Means router 1 is going to add the label, insert the label with your IP packet. Add an MPLS label to the IP packet. And the router who is going to add the label with your packet is called LSR. Which type of router R1 is? Which type of router R1 is? LSR. LSR stands for label
switching router.
Label switch router. Which router is LSR? The router which is adding the label.
I think it is LER.
LSR.
Edge
label
router, no?
switch
LER.
routing.
Switching will happen on R2 and R3.
LSR, the router who is adding the label. This is ingress LSR. Ingress LSR. R1 is ingress LSR, who is going to add the label with your packet. Right? So the customer packet gets labeled on router number 1. Customer packet was normal IP packet, but now it is labeled packet. And which router has added the label? Ingress LSR. Because why router 1 have added the label? an MPLS header? Because R1 is going to forward this to the MPLS cloud now. Now all the router 2, router 3, router 4 are going to receive labeled packet, guys, not normal IP packet. Now this is labeled packet. So router 2, router 3 are not going to check their routing table. Even router 2 and router 3 will not open the IP header. Even if you will trace route, you will find the same TTL, means router 2 and router 3 are not going to decrement in the TTL of in the IP header. TTL value is going to be same in your IP header. TTL value will be not decremented by 1 on router number 2 and router number 3, because router 2 and router 3 are not going to open the IP packet. Yes or no? Yes, guys. So always keep in mind, customer IP packet will get labeled on Ingress LSR router. Now what about these router 2, router 3? Guys, these routers are going to switch the label. What this router will do? This router will replace the label. Let's say router 1 has added, for an example, label number 10. So when router 2 will receive it, router 2 is going to swap the label, will replace the label from 10 to, let's say, 11, right? What will be the label? We'll see that. Soon I am going to show you the practically as well. Don't worry. But the router which is swapping the label, which is replacing the label, are known as transit LSR. This router is called transit LSR. The router which is swapping the label, which is changing the label. This router is called transit LSR. Ingress LSR, the router which will add the label, which will perform label adding, right? And this router is your transit LSR. The router who will swap the label, will replace the label, change the label, replace the label from incoming label to outgoing label. It will replace the label from incoming to outgoing, and we are going to verify the label, incoming label and outgoing label, everything, don't worry. Router 2 is transit router. Router 3 is also going to perform same task. Yes, na guys? It will also swap the label, change the label. So this router is also transit LSR. Let's say here label is 12. Right? And after that, by the way, router 3 will only pop the label, will remove the label. But here I am assuming if router 4 will remove the label, if router 4 will remove the label, and it will send the normal IP packet to customer, because customer don't know about label packet. Customer cannot accept labeled packet. So this router is going to pop the label. Popping the label means removing the label. Router 4 has removed the label. So which type of router it is? The router who is removing the label is called
Egress.
Yes, is called
Egress.
egress. Egress LSR. So we have 3 types of router in the MPLS cloud, guys. First of all, 3 types of router: ingress LSR, transit LSR, and egress LSR. The router who will add the label, who will perform adding label, is called ingress LSR. The routers who will swap the label, will replace the label, are called transit LSR, and the router which will remove the label are called egress LSR. LSR means label switch router. Label switch router. So router 4 is removing the label, router 1 is adding the label. When any user will generate traffic from this subnet 20 to 10, source IP 20.1, destination IP 10.1, at that time router 4 will be your which LSR?
Ingress LSR.
Yes. Router 2 and router 3 means all the provider routers is going to be same, transit LSR, and router 1 is going to be your egress LSR. Any question here?
So how it chooses like we need to go via MPLS. So we have already OSPF running. So we have the same subnet in OSPF. So how it choose MPLS?
We will enable the MPLS. After that, all the routers will attach one label with all the prefixes available in the routing table.
Okay.
Right?
Sir, suppose we have a network connected directly to R3, so R3 will become transit as well as ingress.
So for few traffic, for few packets, it can be transit LSR. For some packet, it can be ingress LSR. For some packet, it can be egress LSR. So it is for packet when the source 10.1 is generating the traffic for 20.1. At that time, router 1 is ingress LSR and router 4 is egress LSR. When source 20.1 is generating traffic for destination 10.1, then router 4 is your ingress LSR. It is for per packet. My PE router, the PE router provider edge router who is receiving traffic from customer edge router, because PE router will be connected to C router if I am going to design the complete enterprise network, which we'll do later. In that case, PE router will receive traffic from C router. So the router, PE router who will receive that customer packet, the first provider router who is receiving the customer packet is called ingress LSR. And the last router who is again converting labeled packet to normal IP packet are called egress LSR. Means provider edge router can be ingress LSR or it can be egress LSR, and all the provider router will be your core MPLS router, that is also called as transit LSR. Hope it is clear.
Sir,
So
one
MPLS.
one
So
more
please.
doubt I
Yeah, go ahead one by one.
Yes, sir. Sorry. Actually, when IP, I mean, when packet received on a router, right, it will check the L2 header and then it goes to, based upon the field, it will goes to L3 header and check the destination. When we have IP MPLS enabled, right? So how the router will treat the packet? How it will decide to look into the
Like when
um,
router 1 will receive the traffic, destination IP address in the traffic is what? 20.1.1.1. It is 20, not 10, 20.1.1.1. So what router 1 will do? Router 1 is going to check SAF table. SAF is enabled, right? So IP SAF and 20.1.1.0. And guys, in the SAP table, MPLS will add one label here. One label here. Right? I will show you that after enabling MPLS. If that label is there in the SAP table, that means router need to add label for MPLS cloud, for MPLS network.
okay.
If there is no label, that means router will forward normal IP packet. But before
So the
performing the lab of MPLS, I need to teach you one more thing. That is how routers are going to assign the label and how it will exchange the label.
got it, sir. So in short, it depends on the SEF table. It should go to either
Yes, I already
MPLS
told you
table or
na. For the MPLS,
yes,
SAP should be enabled. SAP is mandatory. If SAP is not enabled, MPLS will not work. Even if you have enabled the MPLS, but SAP is disabled, there is no benefit.
okay.
So the MPLS is kind of a VPN, right? Like only from source to destination.
Yes, it is VPN only.
So what if there is another subnet in router 1 and wants to reach the other subnet in router 2 instead of 10 and 20? It will use the same method?
Yeah, Same method. Let's say one customer side is connected on router number 2 also. So router 2 is also P router. So router 1 and router 2 can be either ingress LSR or egress LSR.
But in my organization, see, they have internet link and also MPLS link. But they use MPLS only for dedicated customer. It's not shared. Yeah, that's what I mean, how it works then? Like since they, it's like a normal scenario, is it?
Yeah, this is a common scenario, normal scenario. Every time we are configuring same. MPLS for the business critical traffic, or maybe the primary transport, internet backup transport for the general traffic. We are forwarding general traffic over internet because internet is not reliable. Now guys, see one thing, the very important thing. When you will enable the MPLS on any router, what it will do, it will add one label with all the prefixes present in their routing table. Like here, if I will check routing table, so IP route on router number 1, you can see the routes. These are the routes. So once you will enable MPLS on this router, it is going to attach one label with all the prefixes. One label with all the prefixes. Let's say for 10.1.1.0/24, it has attached the label 10. For 20, it has attached the label 11. For 23, it has attached the label 22. And for 34, it has attached the label anything, let's say 20. You can even define the range of label on each router. Like I want router 1 should always assign label from this range 100 to 200. Router 2 should always assign the label from 200 to 300, like that. You can define the range of label. So from that range, it will assign one label to all the prefixes available in local routing table, in the RIB table.
So the same label should be there on all the routers for the same route, is it?
No, all the routers are going to swap the label. Will replace the label.
Basically, so it will work on the normal IP forwarding only, right? The IP subnet should be there in the routing table, only then it will work.
Sorry, brother. Can you speak again?
Yeah, IP route should be there, only then the MPLS will work. Right? Underlying protocol should be some routing, right? Either.
Yes.
Okay.
See, for the SAF, RIB must be there. For the RIB, you have to configure IGP or EGP protocol. Then only SAF table can be created. And for the MPLS, SAF is mandatory, right? So still you need to configure IGP to extend the routes, not to forward the traffic. To forward the user packet, we are going to enable the MPLS here. If MPLS is disabled, then router will use FIB, SAF based forwarding. If SAF is disabled, then router have to use RIB. Router don't have any option. Clear? So guys, here in this scenario, in the routing table of router 1, how many routes are there? In the routing table of router 1, how many routes are there? See 10.1.1.0/24, then 12.1.1.0/24, then 24.1.1. Not 24, 23.1.1.0/24. After that 34.1.1.0/24, and one more network, that is 20.1.1.0/24. Yes or no? This is the routing table of R1. Similarly here, We have same routing table on router number 2 also. We have same routing table on router number 3 also. And we have same routing table on router number 4 also, correct?
Yes.
So as soon as I will enable the MPLS, routers are going to assign the label. Let's say router 1 has assigned one label here for 10 subnet, which is 10. Here it has assigned 11. Here it has assigned 12. Here it has assigned 13. And here it has assigned 14. Similarly, router 2 has also assigned one label with all the prefixes. Let's say 20 for this prefix, 21 for this prefix, 22 for this prefix, 23 for this prefix, and 24 for this prefix. Router 3 has also assigned one label. For this prefix, it has assigned 30. For this prefix, it has assigned 31. For this prefix, it has assigned 32. For this prefix, it has assigned 33. And for this prefix, it has assigned 34. Router will assign label randomly. It can be any number. Label is what, guys? One kind of tag. One kind of tag only. So router is going to select the label randomly. Right? What is the length of label? Hello. Anyone have idea about the length of label? No one? 32 bits. Yes, 32 bits. But out of 32 bits, 20 bits values are used for label. And 3 bits are extra information called experimental bit, EXP. So we can say we have total 20 bits label. So range can be 0 to 2 power 20. And guys, like some IP address, some port numbers are reserved. You know the well-known port number, unknown port number, loopback IP address, private, public. Some IP addresses are reserved. Some port numbers are reserved. Similarly, some labels are reserved and some labels are free. Most of the labels are free. Some labels are reserved. So from the free range, all the routers are going to attach one label. Let's say router 4 has attached label 40 to 10 subnet, 41 to 12 subnet, 42 to 23 subnet, and 43 to 34 subnet, and 44 to 20 subnet. Right? Here what we can do, here we can tell to my router that router R1, you will always assign label from this range only. MPLS label range 10 to 19. Now range 10 range. See, 0 to 16 levels are reserved, not in use. So router 1 is going to assign 16, label 16 to 10 prefix. 16, then 17, then 12, 18, 19, and 20, like that. From 16 it will start. Router 2 will also assign 16 label for 10 subnet, 17 label for 12 subnet, right? And here I can define the range as well, like I can say 100 to 199, let's say, till 200. You will assign label from this range. On router number 2, I can say MPLS label range 200 to 299. Router 3, MPLS label range 300 to 399. Otherwise, it can be confusing for you now because you are learning for the first time. So all the routers are going to assign same label. All the routers are going to assign same label. It can be confusing for you. That's why I am defining the range. And here also I am saying MPLS label range. Range should be what here? 400 to 499. Okay. Done. So now routers are going to assign label from this range. These are, guys, local label. These are local label.
In the real-time scenario, how they are using the range?
Same like this. This is real-time scenario only, brother. Assume that you are configuring real scenario.
In the real-time scenario,
This is real-time scenario.
It's multiple P router is there, no?
Multiple P routers.
For example, for in ISP scenario, it will be hundreds of router. It will be there, no?
In the real time, we can ignore the range. I can use same label on the all routers. Here I have defined the range to teach you, so that router should assign label. Otherwise, all the routers are going to use same label. Router 1 will also use 16 label for 10 subnet. Router 2 will also use 16 label for 10 subnet.
Okay.
In the real time, you will not define the range. Generally, you will not define the range. Okay. Local label. Guys, there will be two label. There will be two label in the LIB table. This is called LIB table. Now, these are local label, but router need remote label to forward the traffic. All the routers need remote label. The remote label is still pending. Means remote label means if I want to forward traffic in 10.1.1.0 subnet, 10.1.1.0 subnet, what should be the remote label? Means if I am receiving a traffic with local label what 10, then it will swap the label to remote label. Remote label can be the router 2 label, but this 10 subnet is directly connected to router number 1. It will not receive any remote label. Even remote label is going to be 20 here. But how you will exchange the label first? How you are going to exchange the labels between the routers? How you will exchange the label? Guys, now let's say router 1 have all the routers has routing table, and we need to exchange the routing tables. We are configuring routing protocol, right? OSPF, EIGRP, BGP to exchange the routing table. Similarly, here we have to configure a protocol to exchange this label table,
LDP.
LIB table, right? And there are two types or two protocols to exchange the label. There are two protocols to exchange the label. First one is tag distribution protocol, and second one is label distribution protocol. These two protocols are there to exchange the label. Right? Nowadays we are not using tag distribution. Tag distribution is Cisco proprietary protocol. Even on the Cisco devices, nowadays we are using LDP protocol. So once we will enable the MPLS on any interface of router, LDP will automatically enable there. Router will automatically enable LDP. And here routers will form LDP neighborship. Router 1 and router 2 will form LDP neighborship. Here we will have LDP neighborship. Here also we will have LDP neighborship. And here also we will have LDP neighborship. And through LDP protocol, routers are going to exchange this label table. Are going to exchange the label table. So guys, router 1 will have label table of router 2 because router 1 has only one LDP neighbor. Router 2 will have two LDP neighbor, router 1 and router 2. So router 2 is going to receive two remote label from router 1 also, from router 3 also. Router 3 will also have two remote label from router number 2 and router number 4 because there are two LDP. So neighbor. So both the neighbor will advertise the label. Right? So router 1 is going to learn one label from R2. Which label? For 10 subnet, router 2 is using what label, guys? 20, right? For 12 subnet, it is using 21. For 23 subnet, it is using 22. For 34 subnet, it is using 23. Means router 2 is advertising this label to R1 24 for 20 subnet. Very good. This router will also have remote label. Two LDP neighbors are there, R1 and R3. R1 is advertising what label for 10 subnet? 10. R3 is advertising what label for 10 subnet? 30. Right? R1 is advertising what label for 12 subnet? 11. R3 is advertising what label for 12 subnet? 31. R1 is advertising what label for 23 subnet? 12. R3 is advertising what label for 23 subnet? 32. R1 is advertising what label for 34 subnet? 13. R3, another neighbor, is advertising what label for 34 subnet? 33. And for 20 subnet, R1 is advertising label 14 and R3 is advertising 34. Similarly, router 3 have also 2 LDP neighbor, R2 and R3. R2 will advertise what label?
R4.
R2 will advertise 20 label for 10 subnet. For 12 subnet, it will advertise 21. For 23 subnet, it is advertising 22. You can see the local label on router number 2 na, for each subnet. The same label it is advertising to their neighbor 23 and 24. And R3 will advertise what label for 10 subnet? 40, 41. For 12 subnet. For 23 subnet, 42. For 34 subnet, 43. And for 20 subnet, 44. Right?
It's on R4 remote.
Yes, sorry, it is R4. R4. And router number 4 has only one LDP neighbor, which is R3. And what label it is advertising? 30, 31, 32, 33, 34. Now this is LIB table, guys. Label information base. Label information base table of R1, R2, R3, R4. Is there anyone who is not clear with this LIB table? Is there anyone who is not clear with this LIB table?
So it
How
means
routers-
all the 254 IPs will have the same label.
All the 254 IP?
Will have the same label.
Where
is
is
it?
255 IP?
/24 subnet.
Yes. Yes.
So
Any IP address from that subnet will have same label. Now, this is like OSPF database, EIGRP database, RIB database, BGP database means BGP table, EIGRP topology table. Now, to forward the traffic, all the routers are going to calculate best label, guys, best label. That is called LFIB table. LIB, label information base. And now all the routers are going to create LFIB table. So LIB table is going to carry all the label, all the remote label and local label. But your routing table, RIB table, carry the best path only, right? But the topology table or database or BGP table carry all the possible path. Similarly, here LDP is going to create now LFIB table, the best label, LFIB table. Where it will store the best label. That table will be used to forward the packet. How? With the help of SAF. R1. See guys.
What is the full form of LFIB?
Label forwarding information base. See guys, now R1 is going to create their LFIB table. In the LFIB table, again, these all submit will be there. Their local label is going to be same, but the remote label, it will check the remote label is best label or not. Remote label is best label or not. So the remote label is 20. Remote label 20 is coming from which neighbor? It is coming from R2. Is it coming from R2? Now router 1 is going to check their SAP table. That in the SAP table, is R2 is my next hop IP address to reach in this subnet? If yes, then I will use the label of R2. Then I will use the same label which R2 is advertising. But guys, this subnet is directly connected on router number 1. Yes or no? So remote label will be not. By the way, you know, I am going to explain one more concept here. After this, when you will understand, router 2 will not advertise label for 10 subnet. For the subnet which is connected on their neighbor device. Like 10 subnet is connected on router number 1, so router 2 will not advertise label. Right now for 12 subnet is also directly connected. 23 subnet guys, 23 subnet is reachable from so IP SAF and 23.1.1.0. You can see it is reachable from R3. Sorry, I am on R4. Let me take you to R1, and here let me run command so IP SAF. So IP SAF and 23.1.1.0. Yes, you can see this subnet is reachable from 12.2. Right, and what label is coming from this neighbor? Because this is the best path. This is the gateway. This is the best path to reach in this subnet. So whatever label is coming from this neighbor, that will be my best label, right? Outgoing label. So outgoing label for 23 subnet is going to be 22 here. For 34 also, again you can see 34 subnet is reachable from 12.2 from router number 2. So whatever label router 2 is advertising, that is best label. 20 subnet is again reachable from R2. So whatever label router 2 is advertising, that is going to be my best label. Let me take you to R2 LFIB table now. R2 is again going to calculate the best label, outgoing label. Here there will be two information: local label and remote label. Remote label, local label and remote label. Remote label. Yes, R2 has how many LDP neighbor? 2. Both are advertising the label. You can see in LIB in LIB table. Now router 2 is going to check SAP table for 10 subnet. Let's understand for 10 subnet first. First subnet 10.1.1.0. So IP SAP 10.1.1.0. Guys, 10.1.1.0 is reachable from 12.1 from router number 1. So what label router 1 is advertising for 10 subnet? 10. That means remote label is going to be what? 10. See, two neighbor are advertising label. One remote label is 10, one remote label is 30. But which one is the best label? 10. And how it has calculated the best label? With the help of SAF. Yes, na? Is it clear? 12 subnet is directly connected. 23 subnet is also directly connected. 34 subnet. 34. Let me check the SAF table for 34. So IP SAF and 34.1.1.0. 34 subnet is reachable from R3. What level R3 is advertising for 34 subnet? 20 or router 2 is advertising. Here it should be like I am on router number 1. Sorry, for 20 34 subnet. For 34 subnet, again you can see 2 level are there.
33.
2 level are there. One level is coming from R1, one level is coming from R3, but in the SAP table we have verified that 30 subnet is reachable from R3. So whatever level is coming from R3, that is best. And R3 is advertising what level? 33. So 33 is going to be my remote level. For 34 subnet, sorry, this is for 34 subnet, 33. And for 20 subnet, again guys, 20 subnet is reachable from R3 only. So IP SAF and 20.1.1.0. Again it is reachable from R3. So what label is coming from R3? 34. So 34 is my best label. Clear? R3 is also going to calculate LFIB table. In there LFIB table also there will be 2 label, local label and remote label. Local label is 30. 10 subnet is reachable from which neighbor in the SAP table? From which router it is reachable? From R2, right? 10 subnet is reachable from R2. So R2 is advertising what label, guys? 20. So 20 is going to be my best label. For 12 subnet, again for 12 subnet, next hop is R2. So R2 is advertising 21 label. These two are connected network. Forget about it for now. 20 subnet. 20 subnet is reachable from which next hop? Which router? R4. And R4 is advertising what label? 44. And on router number 4 finally, we have only one neighbor. So there is only one remote label. So it will not compare. These all are my best label. Only it is going to remove label for connected network 20 and 34. Now this is the LFIB table. LFIB table. Now guys, here I am going to put the LIB table, and here I am going to put the LFIB table on the top. Is it clear to everyone how routers have calculated the LFIB table? If it is clear, then I can now show you the packet flow of MPLS, label based forwarding. Can we move?
Yes.
R1, R2, R3 and R4. See, there is one customer. Customer is generating a traffic with source normal IP packet. Customer is generating normal IP packet with source 10.1.1.1 and destination 20.1.1.1. The user inside one is generating a traffic for another side. It will forward to C router. User will forward the traffic to C router. C will forward to P router, provider edge router. Provider edge router is going to receive normal IP packet. It will compare destination IP address with SAP table. In the SAP table, it will find label number 24, guys. You can see for 20 subnet, remote label is 24. In SAP table, there will be one label 24. So what it will do? This router will become ingress LSR, and this router is going to add MPLS header. And in the MPLS header, it will add the label. Label value is what? 24. Very good. And after that, it will forward to router number 2. When router 2 will receive the traffic, you can see router 2 is receiving labeled packet. It is receiving labeled packet. So router 2 is not going to compare destination with SAP table. It is going to compare this label, the label which is coming in MPLS header with their LFIB table. With your LFIB table. Here it will find where is my local label 24. Here is my local label 24. So what is remote label, outgoing label for 24? 34. So router 2 is going to swap the label from 24 to 34 and then it will forward to router number 3. Router 3 is going to compare again the label which is coming in MPLS header with the LFIB table. Where is my local label 34? Here it is. Okay, so I need to swap this with remote label 44. It will swap the label to 44. And then it will forward to R4. And R4 is going to pop the label, remove the label, and it will forward the normal packet to customer by comparing normal routing table. Even router 4, your P routers are going to receive, guys, unlabeled packet. Router 3 is going to pop the label. You will learn that also, don't worry. This was my MPLS forwarding. Here router 2 and router 3 didn't compare destination IP address. So guys, if route is not available, let's say 20 subnet is not present in the routing table of router 2 and router 3, no problem. Because it has not open even the IP header. Yes, na? It is forwarding traffic based on label. Is it clear? MPLS based forwarding. Let me show you practically. Let me enable the MPLS on all the routers. Here on router number 1, first of all, I am going to enable MPLS. Configure T. MPLS IP. This is the command to enable MPLS. And so MPLS interfaces. Now you can see MPLS is enabled on these two interfaces and even LDP protocol is automatically enabled. And so MPLS forwarding table. What is this? What is this, guys? Your LFIB table. You can see outgoing labels are not there. This is remote label. No label, no label, because there is no LDP neighbor, right? It is not receiving any label from neighbor. But you can see the local label. What label it has attached with 20 subnet? 100, because we have defined the range. What level it has attached with? 101 subnet. 23 subnet 101. And what level it has attached with 34 subnet? 102. And you can see for directly connected network for 10 and 12, it has not attached any label. Means router 1 is not going to advertise any label to router number 2 for 10 and 12 subnet. Right? So router 2 will always pop the label for 10 subnet. When router 2 will receive the traffic from router number 3 for destination 10.1, it will pop the label. Router 2 will forward normal IP packet to R1, because R1 will not advertise any label for 10 subnet to R2. Also, I will enable MPLS on router number 2, config T, and MPLS IP. It is globally and interface range F0/0 and F1/0. Here, let me say MPLS IP. And let me show you the LDP neighbor first, guys. See, LDP neighborship is up between router 1 and router 2. Between router 1 and router 2, now we have LDP neighborship.
Globally also we need to configure.
Yes. You can also enable it through OSP uploading protocol. Now see, LDP neighbor is up. Who is LDP neighbor? Router 2. This is the LDP router ID of I2. So MPLS LDP neighbor. You can check the neighbor. You can see neighbor peer LDP address. Peer LDP identifier means router ID is 23.1.1.2. The highest IP address on R2. If you want 2.2.2.2, then you can create one loopback. It will first, again, because router ID selection is exactly similar like OSPF router ID. First it will look up for loopback, and then physical interface, then highest physical interface, or manually you can configure. So who is LDP neighbor? 23.2. Local LDP identifier, local router ID is LDP router ID is 12.1, and peer LDP router ID is 23.2. The TCP connection you can see here. LDP is layer 7 protocol. And now show MPLS forwarding table. Now guys, see, for 20 subnet, outgoing label is there, remote label. Which label is coming? 201. Means this is the local label for 20 subnet on router number 2. On router number 2, if you will check, so MPLS forwarding table. So here you can see the local label for 20 subnet is what? 201. Which is the remote label on router number 1. Is it clear? One minute, please.
Sir, what is the mechanism of exchanging the labels? How did R2 tell R1 that 10 subnet will be this label?
LDP neighborship. Right, sir? Hello, sir.
Hello?
Yes, come on, maybe sir is on mute.
Yes, guys. Any question?
Hello, sir.
Yeah, go ahead.
Yes, sir, we do have a question.
Hmm.
How did R1 know that R2 is attaching this label 201 for 10 subnet?
See, the
How
router
did
2
they
has advertised there.
communicate with each other?
Router 2 has advertised this LIB na to router number 1. Through LDP protocols, all the routers are going to exchange LIB table. Router 2 will share their LIB table to router 1, and router 1 will share their LIB table to router 2. And it will calculate, all the routers will calculate the best label with the help of SAF. So that's why we are running LDP protocol between the routers. Here is the LIB table of LFIB table of R1, and so MPLS LDP and binding. This is the command to check LIB table. Here is LIB table, you can see LIB table of R1. So R1 is going to share this table to router number 2 to their LDP neighbor. And you can see here for connected network, label is implicit null. It is advertising null label. Router 1 is advertising null label for connected network for 10.1.1.0 and 12.1.1.0. Right? This is LIB, and so MPLS forwarding. This is LFIB. Now let me enable MPLS on all the router. Interface range F0/0 and F1/0, and here say MPLS IP. Here again, now I will have neighborship, LDP neighborship between router 2 and router 3, you can see. And now these routers are also going to exchange LIB table, and after that R3 will also create MPLS forwarding table. Forwarding table means so IP MPLS forwarding table. So MPLS forwarding table. Here you can see, right? This is the local label on router number 2 for 10 subnet, and same label is outgoing label, and router 3 is attaching this label 300. So router 3 will advertise this label to R2. Router 1 will also advertise the label for 10 subnet, and router 2 will use their SAF table to find the best label, right? Here on router number 2, so MPLS, LDP, and guys binding. Here you can see 10.1.1.0, 10.1.1.0, 10.1.1.0, where it is 10 dot, or let's say 20.1.1.0. Here it is
There.
10.
Fine.
First one, right? See, two remote label is coming. One from 12.1 means R1, which is implicit null, and one label is coming from R3, which is 300. So router is going to check SAF table. So IP, SAF, and 10.1.1.0. Oh, the best is like this subnet is reachable from router number 1, 12.1, and what label 12.1 is advertising? Implicit null. So that's why in forwarding table there is implicit null. There is no label, outgoing label for 10 subnet. For 20 subnet, see 20.1.1.0. Guys, again two label are there. Router 2 is advertising 100, and router 3 is advertising what? 304. And see the best label, and their local label is 201. This is local label for 20 subnet. This is the received label from R1. This is the received label from R3. Which is the best label? It will check SAF table. So IP SAF and 20.1.1.0. 20 subnet is reachable from R3. What label is coming from R3 for 20 subnet? 34.3, 302. So this will be your outgoing label. So MPLS forwarding table you can see for 20 subnet. Outgoing label is 302. Is it clear, guys, now?
Yes, sir.
Similarly, on router number 4 also I am going to enable MPLS interface range F0/0 and F1/0 and say MPLS IP. Here also I am expecting now LDP neighborship. Just wait for, you can see LDP neighbor is up, and so MPLS forwarding table. Now all the routers has labeled. Now again, when the user is going to generate normal packet, my P router will receive it, and P router is receiving normal IP packet. R1 is receiving normal IP packet, so it will compare destination with SAF table. So IP SAF and 20.1.1.0, and you can see in the SAF, guys, label is there. Which label is there? 201. So router 1 will get to know that on my exit interface MPLS is enabled, so I need to add MPLS header here, and it will add this label 201. It is going to add this label with the packet. Now this is labeled packet. This is labeled packet. Now it will add this label and forward it to whom? From this interface to 12.2, right? Exit interface F1/0. So it will forward from this interface. Router 2 will receive it. Now router 2 is receiving what? Labeled best packet. So router 2 is not going to open SAF table. Router 2 is going to open forwarding table. So MPLS forwarding table. And in the forwarding table, it will compare the label which is coming in the packet is 201 with their local label. Where is 201? Here it is. So I need to attach this label. I need to replace 201 by my outgoing label 302. It will replace this label with 302. And after that, it will find the exit interface. Exit interface is what? Fast Ethernet 1/0. So it will forward the traffic from Fast Ethernet 1/0. R3 will receive. Again, R3 is receiving labeled packet. So it will check their LFIB table. So MPLS forwarding table. It will compare this label which is coming in the packet 302. Here is 302. For 302, what is outgoing label? Pop the label. Means remove the label. Okay, let me remove the label and forward the packet to whom? Forward the packet to 34.4 from Fast Ethernet 1/0. Let me forward it to R4. And now again R4 is receiving, guys, normal IP packet. So R4 will compare it with SAF table. So IP SAF and 20.1.1.0, and it will forward to customer router, CE router. right? So doesn't matter how many routers are there between P to P, between router 1 and router 4. Those all routers will forward traffic just by checking label. Will forward MPLS based forwarding. These routers are not going to check routing table. From the router number 1, if I am going to guys trace route, if I am going to trace route 20.1.1.1 and source 10.1.1.1 numeric, in the trace route, can I find the TTL value? Here you can see the MPLS. It is going over MPLS. We can do one thing. Here I can capture the link, this link. I am capturing the link between router 3 and router 4. I have captured the link between router 3 and router 4. And guys, what should be the label here? Router 3 should remove the label. Okay, let me do one thing. Let me capture this link. Here, what should be the label in the packet? R2 will add which label? Router 2 will add which label? R1 is going to add, first of all, label number 201, and router 2 is going to add 201 with 302. So here 302 label will be there, 302. Now in the capturing, here you can see, let me do one thing. Let me generate some traffic, ICMP traffic. What happened? Here is my capturing. Let me generate ICMP traffic again. Let me say ping 20.1.1.1 and source 10.1.1.1. See, ping is working, and here is ICMP packet. Let me open any ICMP request message, this one. See guys, the actual ICMP packet, IP header and MPLS header, and in the MPLS header, what is the label? Same or not? 302. Yes, same label is there. And in the IP header, see the TTL value, guys. TTL value is what? 255 only, which router 1 has generated. That means router 2 have not decremented in TTL by 1. Right, and in the MPLS header, you can see what informations are there. TTL. So the TTL value over here is 254. So router 2 has decremented in TTL in the MPLS header, not the actual IP header. So it is acting as a VPN, right? And after that we have label information, label, and what I told you, 3 bits is experimental bits. We'll talk about these bits also. Label is 302. So between Ethernet header and IP header, it has router 1 has added one extra header, that is MPLS header. Is it clear to everyone, the MPLS forwarding?
Sir, MPLS, the interfaces that are in MPLS have no effect on OSPF traffic, correct?
No. While forwarding packet, there is no role of OSPF. Guys, OSPF is used to build RIB. That's it. OSPF is required for RIB. On the basis of RIB, routers have created FIB. And on the basis of FIB, routers has created LFIB. And now to forward user data, routers are using LFIB.
Sir, I'm getting your point. My question was, like OSPF still hello packets or OSPF are being exchanged.
Yeah, so
Am I
OSPF
correct?
is working now.
Like after every some.
Yes, brother.
Okay, but the
OSPF,
same interface is in MPLS.
same interface is in. Here is OSPF packet. For the OSPF, who is going to add the label? No one, na. Here, your router, P router is adding the label with customer packet, not with OSPF packet. Is there any label for multicast address
Yeah, this was
of
my question. That
OSPF?
OSPF is not disturbed.
No. Is there any label for MPLS multicast address of OSPF? No. If router 1 need to forward
So
packet.
sir, if OSPF,
Hmm. Hmm. Go ahead.
so sir, if some bit in between R2 and R3, OSPF will go down, then our connectivity also will go down in MPLS case.
Yes, correct.
Okay.
Now here you can do one thing. See, I am going to guys remove this customer facing interface.
Sir, will there
from
be
the
any scenario like the label gets
scenario like? Your voice is not coming.
will the label gets randomly assigned?
Yeah.
Hello?
Yes, of course.
Yeah, okay. It is like
MPLS.
my question is like every time do we need to uh, mention the range
See, I have removed this
of
range
label?
command and interface range F0/0 and F1/0. I am saying no MPLS IP. LDP neighbor symbol goes down, done. And let me enable the MPLS again, IP MPLS. And so MPLS forwarding table. Now see the local label, wait for some time. So MPLS LDP neighbor. What happened? Why neighbor is down? I think I have disabled the OSPF. So IP OSPF interface brief. Okay, let me enable OSPF. Now I am only advertising OSPF on this interface. IP OSPF 1 area 0. And now LDP neighbor. So MPLS LDP neighbor. So MPLS interface brief. Not brief. Interface enable. So MPLS LDP neighbor. Okay, done. And so MPLS forwarding table. Now you can see it is assigning label from 16
Randomly. Okay.
randomly.
Okay, sir.
Yes, all the routers will start assigning label from 16. Now here guys, I am not advertising the customer network in OSPF. Here you can see so IP OSPF interface brief. OSPF is only enabled on which interface? F1/0. Even I am going to disable the MPLS on customer facing interface F0/0. No MPLS IP. We'll do same thing on router number 4. Config T. No router OSPF1 and interface F1/0 IP OSPF1 area 0 and MPLS IP. And on interface F0/0 no MPLS IP. Very good. Now you can see here so IP route OSPF guys through OSPF. So IP OSPF neighbor. What happened? Okay, neighbor is in two-way state, but here now we will not receive the side 1 prefix on router number 4 because we are not advertising this LAN into OSPF because this is service provider network. So between P to P, we'll advertise the customer prefix through BGP. Let me create one loopback here on router number 1. One loopback, interface, loopback 1, IP address 1.1.1.1, 255.255.255.255 and go to router number 4. And on here also I am enabling OSPF, IP OSPF 1 area 0 and go to router number 4, config T, interface loopback 1 and IP address 4.4.4.4 255.255.255.0 and IP not 0 255 and IP OSPF 1 area 0. Very good. So IP OSPF neighbor. Now so IP route OSPF 1.1.1 is coming. Now 1.1.1 and 4.4.4 are reachable. Ping 4.4.4.4 and source 1.1.1.1. Both the loopback are reachable through OSPF. Both the P, there is reachability between P to P. Let's create the BGP session here. Router BGP AS number 100 and neighbor 4.4.4.4 and remote AS 100. Remote AS 100 and on router number 4 also, let me say router BGP 100 and neighbor 1.1.1.1 and remote AS of neighbor is again 100 and neighbor 1.1.1.1 update source loopback 1. That's it. Now I am expecting BGP neighborship here. You can see BGP neighborship is up. So IP BGP summary. Very good. Now let's advertise the customer prefix in BGP. Router BGP S number 100 and network 10.1.1.0 mask 255.255.255.0 and go to router number 4 and here also let me advertise customer prefix in BGP router BGP 100 and network 20.1.1.0 mask 255.255.255.0. Done. Now see so IP route BGP. Guys, side 1 prefix is coming here on P2 router and on P1 router also you can verify. So IP route BGP. Side 2 prefix is also coming but on the P router on router number 2. So IP route. Here we are not able to see the customer prefix 10 and 20. Am I right? Here so IP route 10.1.1.0 customer networks are not there in the routing table of provider router, but ping will work or not? Ping 20.1.1.1 and source 10.1.1.1. Ping is working, you can see. Getting my point? How ping is working? When P1 router will receive the normal traffic, again IP packet, normal IP packet. What router 1 will do? Router 1 will compare the destination with SAF table. So IP SAF 20.1.1.0. Guys, label is what? 204. It will add the label 204 and then it will forward to which interface? F1/0 to 12.2 from this interface. Router 2 is not going to check routing table. Router 2 is going to check LFIB table. So MPLS forwarding table. Okay, for 204 local label, remote label is going to be 304. It will swap the label. It will swap the label to 304 and then it will forward to which interface? Fast Ethernet 1/0 23.2 means router 3. See, route is not there. R3. Again, R3 is going to check LFIB table. So MPLS forwarding table. Local label 304. Here it is. I need to pop the label. I need to forward traffic from this interface to router number 4. Let's remove the label and let's forward the normal IPP packet to router number 4 and router 4 has routes. So IP SAF 20.1.1.0. Getting my point? How service provider routers are going to forward the traffic now? Is it clear, everyone? This is so important, guys. If anything is not clear to anybody, please ask. This is very, very important.
Very clear, sir. Thank you so much.
Very clear. Very good. So now we are done with MPLS, BGP, MPBGP, L2 VPN, L2 MPLS VPN, L3 MPLS VPN, and MPLS forwarding. Any question? Let me check the chat. 5 clear, sir, clear, sir, clear, clear. Great. Now it's your turn to test everything. Right, guys, define the label range on the router, and according to the label range, create your own LIB table and LFIB table, and after that verify it on the router. If you are able to create the same table, that means you know the MPLS very well. And after that, try to check the packet flow like this. Generate the traffic from the user, and then check the SAP table on first PE router, and then MPLS forwarding table on PE router, right, till the destination. Here you can do one more thing. Here you can connect your CE router. Here you can configure one router, that is going to be your CU router, and here you can configure BGP, eBGP. Here again you can configure CE router, you can configure eBGP, and here are my users, LAN. And then you can test. This is the same topology which we had seen in the L3 VPN, yes, na? Yes, this is the same one. In the service provider between P1 to P2, guys, there will be multiple paths. So that's why we have BGP session with the help of loopback interface. Right, so you can test these all things. Now it's your turn. That's all for today.
Sir, are we going to cover VPLS?